Okay, before we start our discussion, it is a very good news for us that Ananya Ranade from our class has got silver medal for the country in European Girls Maths Olympiad. So all of you are requested to switch on your mic and give her big hands. Very good. It is it is
Thank you.
not an easy examination. It is equivalent to International Maths Olympiad, and the problems are really difficult. However, Ananya has done it very well, and she has been player of this game for a long time now, and without any display, she is managing these things very well. So, hearty congratulations to Ananya from all of us from Prakash Institute, especially this class, because
Thank you.
you have been part of this class since 8th standard. Okay, so she has also scored very good marks in INMO this year, and there is every possibility that she will be selected for the camp. And not because she is girl, but she is otherwise also selected because of the numbers that she has got. So for all practical purposes, she is, we can say, as far as maths in our country is concerned, she is amongst the first top 35 students in the country if she is selected for the camp. So that is also a very good achievement. Uh,
Thank you, sir.
Good, well done, Ananya. All the best. Okay, so we should go back to our definite integral. We have solved many problems as application of our properties of definite integral last lecture, and therefore we move now. We have developed a formula for definite integral, which is a limit of sum. I would like to write the formula again, which we have done it a couple of lectures before. It was like this: integral a to b f of x dx, which is equal to limit h tends to 0. Inside multiplied by h, inside we have taken that width common, and then it was f of a plus h. If we are taking the rightmost point as our k point, then first point will be a plus h, f of a plus 2h plus dot dot dot, plus last point will be f of a plus nh. Okay, the geometry behind this was like this. If suppose first point is a, last point is b, if we are dividing them in equal parts, total n number of parts, so this was xn minus 1, etc. Width of each is h, so there are n h intervals, so this is what nh plus a. Okay, and we have taken out h common, and what we are saying is h tends to 0, h tends to 0, so number of intervals go to infinity, n goes to infinity, and we know n into h in this case b minus a. So this is the first thing that we have developed when we learned definite integral. Maybe if this limit exists, then we call this as definite integral, and we represent it like this. And then we, by using fundamental theorem of integral calculus, we connected this definite integral symbol to something called antiderivative. So limit of sum is first, then we defined it as a definite integral if it exists, if that limit exists. And if it is definite integral, which we have connected to indefinite integral, to be evaluated between A to B, which we say it's a fundamental theorem of integral calculus, and therefore we have a method of finding out antiderivative and evaluating it to these upper and lower limits. In other words, we can take the limit of sum and find out the numerical answer using this method now. So question will look like this, which is sum of the series. Suddenly you will realize that if we could convert that series in the form that we want, essentially in this form, and if h tends to 0, then we can directly write that summation as definite integral of some function f of x. Of course, this function will be displayed here. We need to identify that function and write it here. And of course, this a and an h plus a, this is b, a and b, will be displayed in this summation, which we have to put as lower and upper limits, and then go via antiderivative method to find out the numerical answer. That will be the answer for this summation. That is the whole idea, and we would like to solve few more problems using this idea, but let us work on this and convert it into a form which is going to be usable for us. By keeping a and b, the purpose is not going to get served because we need to have numbers over there. So we say a is equal to 0, we say b is equal to 1, so nh becomes 1, right? And therefore h is equal to 1 upon n. So if we substitute this in the above formula, we get the formula integral 0 to 1 f of x dx is equal to limit n tending to plus infinity, n tends to infinity, and it is a natural number because counting is taking place, first term, second term, etc. We have to replace h by 1 upon n inside bracket. A is 0, so it is f of 1 upon n plus f of 2 upon n plus f of 3 upon n plus dot 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 plus f of what? N upon n, practically. Do you appreciate this? N upon n. I am not going to write it as 1, but it is n upon n, where this n is tending to plus infinity. So in summation notation, we can write it as limit n tends to plus infinity 1 over n sigma r goes from 1 to n f of 1 over r over n. This is important. This is integral 0 to 1 f of x dx. This is the derivation. You can consider it as proof of this formula. So a given summation is to be brought in this form, and then it has to be integrated using our antiderivative technique. Let me explain you with one example, and then you are supposed to solve at least 8-9 examples. So of course I should take the easy one for me and give you difficult ones. Okay, anyway, I have got first example as limit n tends to infinity Here I will not write plus infinity because it is a natural number. N upon n square plus 1 square plus n upon n square plus 2 square plus n upon n square plus 3 square plus dot 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 plus n upon n square plus n square equals. Now why should I solve any problem? You should solve this problem. So I give you sufficient time to solve it. The idea is this is looking like this. Get it in sigma notation like this. Identify the function. Put it over here and try to find the antiderivative and the answer. Couple of few minutes I give you. Do it. Answer for this is pi by 4 and the function this is equal to integral 0 to 1 dx upon 1 plus x square, which is tan inverse x 0 to 1, which is pi by 4. Next problem. Limit n tends to infinity 1 upon n sec square pi by 4n plus sec square 2 pi by 4n plus sec square n pi by 4n. Is equal to. Okay, answer for previous question is 4 by pi. New question, limit n tends to infinity 1 upon n plus 1 plus 1 upon n plus 2 dot 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 plus 1 upon 3n is equal to. Now this is equal to, I can write it as sigma notation, limit n tends to infinity sigma r goes from 1 to 2n 1 upon n plus r, right? So when we develop formula, this was n, now it is 2n. So how many parts are made? Total number of parts 2n. And what is the, if we go and look at the formula again, here NH was equal to 1. Is that correct? Yeah. Yes. So if this was n, then this would have been 2n here. 1 upon 2n, we should stop at n. That means n parts are done. But it is 3n, therefore n plus 2n. So there are 2n intervals which are made, each of width h. Okay. And therefore, if we still consider nh is equal to 1, then 2nh will be equal to 2, and therefore this we should write as integral 0 to 2 okay, if at all if we could convert it into the form of this. So how do you convert that into 1 upon n sigma f of r by n form? So if you take out n common, then we will get 1 upon n sigma r goes from 1 to 2n, limit n tends to infinity. If we take n common, then we have inside bracket 1 upon 1 plus r by n. Okay, therefore our function is f of x, which our function is 1 upon 1 plus x. Our r by n is x, right? So r by n is x, dx. So we are supposed to solve this integral, and it is simple. It is log 1 plus x to be evaluated between 0 to 2. Log 1 plus x to be evaluated between 0 to 2. Log 1 is 0 and log this is equal to log 3. Hence the answer for third question is log 3. Okay, next. Fourth problem. Limit n tends to infinity 1 upon 1 plus n cube plus 1 upon 8 plus n cube plus 1 upon 27 plus n cube plus dot 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 plus 1 upon what 2n. What is it correct? Last term. Or 2n cube it should be, I think. 1 cube, 2 cube, 3 cube, n cube plus n cube. Yeah, 2n cube. Do it. Mistake. It is not 1 upon 1 plus x. First term is correct. Second term is 4 upon. Third term. I don't know. Then my last term also could be little different. This is 4 upon 8 plus n cube. 9 upon 27 plus n cube, and the last term was 2n, 1 upon 2n. Now I think it should be 1 upon 2n, which is correct. Check whether you can solve this. So this is limit n tends to infinity. Sigma, if I, this is 1 cube, 2 cube, 3 cube. So last term will be 1 upon n cube plus n cube. Sorry, not 1 upon, and numerator is n square, 2 square, 3 square. So n square. And therefore it becomes n square upon 2n cube, therefore 2n. So sigma r goes from 1 to n, 1 upon, instead of 1 upon we should have r square upon r cube plus n cube, right? So we want 1 upon n common out. Without that we cannot apply that formula. Limit n tends to plus infinity 1 upon n. If we pull out and then put this r square in the denominator, then what will we have? 1 upon r cube upon r square is r upon n plus n square by r square. Is that right? Yes. So n by r is our function. So I can one more step if you want. Limit n tends to infinity 1 upon n inside bracket 1 upon r by n plus 1 upon r by n square. You should put everything in terms of r by n and then replace 0 to 1 f f of this quantity, which is 1 upon x plus 1 upon x square, 0 to 1. Okay, which is integral 0 to 1 x square upon x cube plus 1. Put x square plus 1 is equal to t. You will get 3x square dx is equal to dt. Therefore, x square dx is equal to dt by 3. This is 1 by 3 integral. If x is equal to 0, t is equal to 1. If x is equal to 1, t is equal to 2 dt upon t, which is log t. 1 by 3 log t to be evaluated between 2 to 1, which is 1 by 3 log 2. That is the answer. Now, can you imagine this summation has answer 1 by 3 log 2? This is only possible because of the calculus differential, because logarithm and algebraic, this is algebraic summation. As n tends to infinity, it is a summation of some algebraic terms, and suddenly that value becomes log of 2, 1 by 3 times log of 2. Question number 5. Limit n tends to infinity, inside bracket 1 upon n, I should write it carefully, 1 upon radical n square minus 1 plus 1 upon radical n square minus 2 square plus dot 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 plus 1 upon radical n square minus n minus 1 square. Find out. There are minor changes. The only difference in this problem was sigma was going from 0 to n minus 1. That means you are picking up the leftmost point as your k value in that interval. Therefore, this is equal to integral 0 to 1 dx upon radical 1 minus x square, which is sine inverse x, to be evaluated between 0 to 1, and the answer is pi by 2. Okay. Next problem number 6. Limit n tends to infinity 1 plus root 2 plus root 3 plus n root n. Answer for this is 2 by 3. Question 7. minus log n. Okay. Suppose we give 1 by n to this last term also, then it will become n log n. So 1 upon n inside bracket n times log n, and there are n terms here. So every log n is given to one term. Therefore we get log n plus 1 upon n plus log n plus 2 upon n plus dot 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 plus log 2n upon n. If we absorb this term inside the bracket. Okay. And therefore we should be able to write down the general term in sigma notation, which is equal to limit n tends to infinity 1 upon n. What is this? Log n plus r upon n. Sigma r goes from 1 to n log n plus r upon n. We want to bring it in r by n form. Therefore, we take out n common from the first. We get this bracket sigma r goes from 1 to n log 1 plus r by n. That common n gets cancelled with denominator. So this is what is your formula, which is going to be integral 0 to 1 f of log of 1 plus x. Is that correct? Dx, which is 1 plus x log x correct, to be evaluated between 0 to 1, which is equal to 2 log 2. When you put 0 here, it becomes 1. 0 here, log 0 is.
It should be 1
Sir,
plus x
minus x
log 1 plus x minus x.
1 plus x log 1 plus x minus x by
Yes, sir.
Parvila, चुकला. Minus 1 plus x. Question number 8. Limit n tends to infinity 1 upon n raised to m plus 1 inside bracket 1 raised to m m not equal to minus 1. Find out. 1 upon m plus 1. Very simple. Ninth problem. Limit n tends to infinity sigma r goes from 1 to n upon r square plus 2nr plus 5n square is equal to, what हो गया, how do you adjust this? Limit n tends to infinity, 1 by n sigma r goes from 1 to n, 1 upon r by n plus 1 bracket square plus 4, which is equal to integral 0 to 1, 1 upon x plus 1 square plus 4, which is equal to half tan inverse x plus 1 by 2 to be evaluated between 0 to 1, which is equal to pi by 8 minus half tan inverse half. I have got 10th problem written with me, but I don't have solution or answer. Maybe you tell me the answer. Last problem of limit of sum. Limit n tends to infinity, sigma n square into sigma n cube on sigma n raised to 6. I'm not sure whether this is correct problem or not, but you are the right person to tell me whether I should put this in my notes or remove it. करा कष्ट जरा बघूया. Okay, ignore that problem. I will check what is the source and make it correct next time. Okay, let us move. So this is what is limit of sum type of problem. So if at all you get, not that every problem will be solved by limit of sum, you will have to use telescopic skills, you will have to use binomial skills, and you will have to use limit of sum skills to solve. And see, now we are solving limit of sum, therefore it is easy. But to identify the problem belongs to which category, whether it belongs to binomial, whether it belongs to telescopic, or whether it belongs to this limit of sum, that is the skill that you are required to develop and solve accordingly. Okay. Okay.
Sir,
Yes.
sir, is this in a way the
Okay, so now let us use definite integral to find the area under the curve. So therefore, if your question states that you are supposed to find out the area entrapped or area under the curve or area between function and so and so and so and so different lines, then you will have to consider some sign changes, because when it is definite integral, we are not bothered about whether it is a positive area or negative area. But when it is area entrapped, when you are supposed to find out area entrapped between the different curves, then that area will have some value and it has to be a positive value. You cannot say at that time that area is minus 5 units square, but because you are supposed to find the area. So as we solve problems, we will come to know the nitty-gritties of that. So first problem, simple problem. Find the area trapped between y is equal to sin x and x-axis from 0 to 2 pi. Okay, so what we are talking about is this. 0 pi 2 pi sine and x-axis. So area can directly be given as integral 0 to 2 pi sin x dx. What we will make? Error in this. Why? If we just solve this as definite integral and not consider, if we solve it for I and not A, what will we get? Minus cos x to be evaluated between 2 pi to 0. So you will get answer 0. Right? So it is a definite integral, correct answer. But if you are solving it for area entrap, I mean, we can see some area entrap between the curve and x-axis, so we might as well find it out. And therefore, what we will have to do is, we will have to break it into parts, 0 to pi and pi to 2 pi. So area is equal to integral 0 to pi sin x dx plus integral pi to 2 pi sin x dx. Again, I mean, we can put absolute value everywhere because we wanted to find out. If absolute values are not there, these two areas will get cancelled because they are equal. Okay, so that is what is, either you write absolute value or you take a consideration of that interval and add those areas eventually. So now it is minus cos x be evaluated between 0 to pi and then put absolute value sign plus absolute value minus cos x be evaluated between 2 pi to pi and take absolute value. So how much it is going? Cos x cos pi is minus 1. So minus 1 minus 1 1. Cos 0 is 1. So minus of minus, so plus 1. This is first absolute value, plus minus of cos 2 pi is minus 1. And minus of cos pi is minus 1 and minus of that is plus 1 and minus in between, so minus 1. So it is 2 plus 2, 4. Answer is 4. Area entrap between sin x and x-axis between 0 to pi is 2, pi to 2 pi is 2, therefore total is 4. Check whether you are understanding. Next, question number 2. Find area of ellipse. Okay, so because this is first, I will write the solution. Ellipse looks like this. And therefore, we should solve it for 1/4. This area, if we find out it is good enough, it is from 0 to a. F of x is, we'll have to find out what f of x is. Y in terms of x, we should be able to write. So b square x square plus a square y square is equal to a square b square. Right? So a square y square is equal to a square b square minus b square x square. Correct? So b square by a square y square is equal to b square by a square inside bracket a square minus x square. And therefore, because it is a first quadrant, we can say y is equal to plus b by a radical a square minus x square. That is our function. And therefore area, which is area of ellipse is going to be 4 times whatever area we calculate now. Area is equal to area of first quadrant, say, is equal to integral 0 to a b by a radical a square minus x square dx, correct, which is equal to b by a inside bracket x by 2 radical a square minus x square plus a square by 2 sine inverse x by a to be evaluated between 0 to a, correct, which happens to be equal to 4, I mean b upon a inside bracket a square by 2 minus a square by 2 into pi by 2, no? Correct. So a cancel 4. This is equal to pi a b upon 4. So area of ellipse total is going to be pi a b, right? Okay. Question number 3 on area. Find area enclosed by. The parabola y is equal to x square minus 4x plus 5 and the line y minus x is equal to 1. First required आधी पहिलं डायग्राम काढली तर आपल्या लक्षात येईल. If we sketch, we will come to know that 1 comma 2 is first point and 4 comma 5 is another point. The parabola will go like this, straight line will go like this, and you are supposed to find out this area. Okay, so you find out this area. And you subtract this area, right? Okay, therefore integral 1 to 4, this is 1, this is 4, you need to solve them simultaneously and you get this. X plus 1 is the first function, integral 1 to 4 x square minus 4x plus 5 dx, and I think they are the simplest possible functions that you can come across. Next one. The parabola y square is equal to 16 ax and the circle x minus 8a square plus y square is 100 a square intersect in A and B. Find area enclosed by minor arc AB, minor arc AB of circle and arc AB of parabola. Take your time. Okay, so answer for this I will write, you check whether you get it or not. Answer is okay. Let me write down the solution. The geometry is like this. You have a circle. You have x-axis, y-axis, right? This is the center, sorry, not y-axis, this is the center of the circle. Okay. Center of the circle, let me call it as C. Then there is a parabola which is cutting like this. Of course, symmetric with respect to x-axis. Let me call this point as E. Let me call this point as origin. This is A and this is B. C is at A comma 0. Radius of circle is 10. Therefore, this C is at A comma 0. E is going to be 6A comma 0. Because if you substitute x is equal to 0, 16x, no? So if you substitute y is equal to 0, then E is going to be equal to, no, substitute y is equal to 0. We have to solve them simultaneously to find out x coordinate of A and B, which is going to be 6A. I hope you have solved it. Origin is 0 and this point here is say D. It will be minus 2A comma 0. Okay. And you are supposed to find out the area between the parabola and minor arc. Okay. So first we should find out the area of this sector. E is 6A comma 0 and D is minus 2A. So area of, we have to use the curve of circle first to find out, let us say, green area, and then we have to use parabola to find out blue area, and then we subtract, right? That is the idea. And therefore required area is going to be 2 times integral minus 2a to 6a. Radical equation of circle put in explicitly mentioned form. 100a square minus x minus 8a bracket square. So this is the area of circle and x-axis between minus 2a to 6a, and you are supposed to subtract. Let us take this 2 out. You are supposed to subtract integral 0 to 6a and equation of parabola, which is radical 16ax dx. Now it is your indefinite integral skill that you should use and solve this. So let me write down. Area is equal to 2 times inside bracket x minus 8a upon 2 radical 100a square minus x minus 8a bracket square plus 100a square upon 2 sine inverse x minus 8a upon 10a to be evaluated between minus 2a to 6a minus 2 times 4 root a into 2 by 3 into x raised to 3 by 2 to be evaluated between 6a to 0, right? So this is equal to 2 inside bracket minus a radical 96x square plus 50a square sine inverse 1 upon 5 minus 50a square sine inverse minus 1 bracket complete square bracket complete minus 2 times 4 root a 2 by 3 into radical 216 a raised to 3 by 2, which happens to be equal to 20a square side bracket 5 cos inverse 1 by 5 minus 2 root 6. That is our answer. Now, there is nothing difficult except it is long and except it has some bad terms for integration. Okay, let us solve one more problem. Find the area bounded by the parabola. Y square plus 1 is equal to 2x and x minus y is equal to 2. Now, first thing that you need to notice is this is horizontal parabola and a straight line, something like this. So it is better to consider y as independent variable and x as dependent variable. Therefore, these 2 points you will get 1 comma minus 1 and this is 5 comma 3. Okay, so first total area is integral minus 1 to 3, that is y coordinates. Straight line given is y, x is equal to y plus 2 dy minus integral minus 1 to 3 x is equal to y square plus 1 by 2 dy. This is what is the required area. So because limits are same, what we can do is this is y square by 2 plus 2y minus y cube by 6 minus half y to be evaluated between 3 to minus 1. So what do we have? Is that correct? What am I writing is correct? Yes. So we have this term minus y cube by 6. We have square only one square term, so plus y square by 2. And what happens with these two guys? Plus 3 by 2 y to be evaluated 3 to minus 1. Okay, so let us put it now. 3 3 9 3 minus 27 by 6 plus 3 3 9 by 2 plus 3 3 9 by 2. This is first upper limit minus 1. If I put minus will get cancelled, it will be 1 by 6 plus 1 by 2 plus 3 by 2. Correct? So how much is this? Now I think we should make the denominator, let us make denominator 6. So now 3 27. This and this is same. Okay, so they get cancelled. This is 9 by 2 minus, if I make denominator 6 here, this is 1 plus 3 plus 9. Now udaharan 13. Correct? तरी पण माझं पण चुकतच आहे.
सर ते -3/2 हवं.
इथे ना, when I put minus plus, this is minus. I should have minus 3 by 2 here. So if it is minus 3 by 2, this is going to be minus. So it is minus 5 by 6 minus plus 5 by 6. अरे
तर ते 16/3 येते.
So how much is this? Now 27 भागिले 6, 27 plus 5 upon 6, which is equal to 7 आणि 5 बारी 2 32 by 6. 16 32. This is the correct answer. Might as well you check it. Okay, that was the last problem of the day. Stop recording.